Hey guys, welcome to the sixth and the last part of this series where we were talking about Three.js, React-Three-Fiber and React-Three-Drei. In our last tutorial, we left our progress at this position where we had a surrounding, an environment, a blue colored environment, and it radiated light, and the light is, well, reflecting off the surface of the sphere here. We talked about material, we talked about the different kinds of material and the properties, and lastly, what we did in the last tutorial was animating it with GSAP so the ball appears to be bouncing. In this video, we are going to be looking into how you can load your own models and not just simple objects like what Three.js offers right out of the box. We are going to learn how to use GLTF files, how to place them, and how you can maybe play around with them. So I'm Soham. Stick with this tutorial towards the end and let's see what we can do. So we're going to load a model here now. If you don't know what a model is, well, let me take you back to GIMP, the one software I use always for drawing. All right. So in our last tutorial, I think it's the last or the second last probably. I think what we did was, let's take the blue color. Yeah. So what we did was draw a simple sphere. We didn't draw, we created. Yeah, I mean, that's the right word. So we had a simple sphere and it was spherical. It was using sphere geometry, but it was one geometry, right? I mean, it was not a combination of too many geometries placed under one container or one sort of thing. It was something very simple, so it takes very less space to fetch from the server and store. Now, what you have, if you had something complicated, say for example, you had a sports car, maybe you had a statue, maybe you had a bottle, well, those objects are not as simple as maybe drawing a simple cylinder or drawing a simple rectangle. They're much complicated, right? And since they're complicated, they are a bit larger in size than your convenient web payloads. Now, if you download a web page, it might be a few kilobytes. If you download a model, do understand that some models can be quite huge in size. So let me, for this tutorial, what we are going to do is that we're going to place a model right here in the center, something complicated, but we're not going to create a model. We're going to download one model from somewhere. We're going to find it from a site. I'm going to show you, and we're going to place it here, and then we can see how we can play around with it. And you will see that the same way you can manipulate a mesh like the sphere mesh here, you can manipulate a model just like in the same manner. So we go to a site called Sketchfab. I have it in my bookmark here. I think where is Sketchfab? Do I see it? Yeah. Just go to Google and search for Sketchfab. If you don't know what Sketchfab is, it's a fantastic website where you can find out really cool 3D models, and some of them are free to use and download and use, but you should always pay attention to the licenses because, well, I think there are some paid ones as well. So you make sure you have the license if you want to do something commercial with them. But that being said, let's look at this. It looks really cool. And the cool part about this website is that you can really see those 3D models in action before downloading them. So that makes it even easier for you. So this model right here, it's 3D. You can see this in real time. And if you download this, this is what you're going to get. But you see that it takes so much time to even fully download. You saw that loading bar up top, right? It shows that the textures on this are very high and it almost looks, I mean, look at the quality of the wood. It's so realistic. Someone who made it like took a lot of time just mapping everything. Like even look at the chair, this little thing here where the leather has, worn off with time. Maybe it looks so realistic. From up here it looks so beautiful. So we're going to be using some model like this. Now in our ball and light, this wouldn't look good. Yeah, we need something. Let's okay, this is a beautiful car right here. Let's search for some models. Okay, let's search for some models. It's a good exercise having an eye for models. Not every model will look good with the kind of lighting we have, and that is also important to consider. If you place a model in, well, where you have light, then light interacts with everything, models included. And the pictures you see here, well, they are made to look that way with a certain light. So this statue that appears silver here will obviously look to be a different color when placed under, say, blue light. So we're gonna look for something that goes really well with the bluish color that we have. Do we want a sports car or maybe a statue? We have a bear, we have an Inca temple, we have some pottery. Okay, we have, okay, I need to narrow down my searches. Let's look for maybe a car. And let's switch some filters. It must be downloadable, and I don't want the standard and the editorial because they're not free to use, and I won't be using those for this tutorial. I'll be only using the ones that are available for free and for non-commercial purposes. Free for non-commercial. And let's see. Man, these are some really, really good ones. But I'm looking for one that goes well with... what kind of a car do I want? Okay. Lots and lots. I think Bruno Mars used a cars like kind of. If you don't know who Bruno, I think it's Bruno. No, no, it's not Bruno Mars. It's Bruno Simon. He's a guy who created this awesome 3D portfolio, which is a game in itself. You can just Google Bruno Simons. I think that's his name, and you will see his portfolio. Go check it out, and you will be amazed at what he did. I'm wasting way too much time with this video. I mean, just wasting too much time choosing something. This looks cool. Would have been great if this was in white, but let's also take this one. And we're gonna be using just one. I'm just shortlisting some stuff. Okay, we had enough of cars. I think we're not gonna find anything we want much. So let's look for something whitish, maybe a marble statue. I'm just making my choices here, you know, just finding something I can use. And I hope YouTube doesn't ban me if I show nude models. Shit, I didn't say that out loud. Don't cancel me. What a weird statue. What am I doing in this video? This is cool. Okay, I think we can go with a car. Oh, whoa. Okay, this is a real high definition car. Maybe we can use a car. Maybe. Okay, let's go with this 1975 Porsche model. It looks really amazing. I mean, well, but it's gonna be huge in size, and I can tell that. But if you look at the number of triangles and vertices it has now, remember, like I said, that a model is a combination of several what you can call, I don't know I don't know the exact term, but I think it's called nodes and vertices. Nodes and vertices mean the same thing. Well, let's assume a circle like this. If you remember, we had width segments and height segments of a sphere of a spherical geometry. So what that means is that you have certain vertices that you can join these together, and when you have many such vertices all joined together, they create what is called segments. That was segments, right? So you have nodes here. You have a node here, you have a node here, one here, and so on. So then the more the number of nodes you have, well, the more detailed your models would be, right? I mean, look at this. You think the creator of this model just used a few nodes to create this? No, they used thousands, and this actually lists the number of vertices, 133,000 points on this car. That and the reflection on this, top notch. So we're gonna use this. I'm not gonna waste too much time for this. So any model would work. Go ahead and download it. Even if it's not this site, just choose anyone, but make sure to use the correct format. Now I'm gonna be using the GLTF format because I found that to be the easiest one I can work with Three.js. So go ahead and download that. Make sure it's GLTF. And I'm gonna click on download, and it's 67 megabytes. Whoa. Now, while this gets downloaded, just understand it that when you are creating something for the web, you don't want your users to be spending too much time loading the web page. So 67 megabytes isn't something you want your user to download to see your page. Now, that being said, if you're making a game with Three.js, then maybe you can go for higher sizes like this, because if you're using a game, people are, well, willing to download more than if they're just looking at a common web page. Now, while this gets downloaded, let me show you one more thing. If you're using VS Code, there is a fantastic extension for viewing GLTF files. And that's right. VS Code is not just for code. I mean, it's become such a diverse IDE that I'll say it's an IDE now. I mean, it's not just some sort of editor. It has become an IDE of its own. And there's an extension. Just go to the extensions page, type in GLTF, and you're going to see this one extension, GLTF tools, which you can download. And when you do that, you can actually see these models in VS Code. I'm going to show you. So I already have this. I'm not going to install this. You can go ahead and do that, GLTF. And then I think it's done by now. It is done. And I will extract this. Now, I was using Vue.js for this project. So I have the project directory somewhere, right? Yeah, I have it here. I think it's in my downloads. And I'll make a directory, and what I'm going to show you now will be compressing the model, because 7 megabytes is way too much. So we're going to find a, I'm going to show you a way to compress the model before using it in your actual site. So understand this. These files that you see here, just this license file, you can say this later, and this file, the scene.bin, the scene.gltf, and the textures, when you fetch a GLTF model, you are not just fetching the GLTF file here, you're also fetching the bin and the textures. If you were using Three.js, what you would do is that you place this folder and these two files in the same directory and make a fetch call for the GLTF with, I think it's called the texture loader. There is a texture loader class that I can use for Three.js. If it was Three.js, you would do that, and fetching the GLTF would also fetch these two. So they need to be in the same folder. Now we are using React-Three-Drei, so it has its own helper, much convenient helper that will help us to use this. But we need to compress it, and I'll show you what you can do. For now, let's create, and you need to place these files where they are directly accessible for users. So maybe a public directory. So remember then that your users have to hit that directory in order to fetch that. Because if you are using React, maybe if you had an image, what people normally do is say, well, import, they do something like import some image from, and then an image path. But you can't do the same. You cannot do the same with the GLTF file, and that's because, well, React doesn't understand what a GLTF is, so it wouldn't know what to import from that GLTF file. So in Three, what you do is you create a new folder, you call it public, that's the convention, and that's what it needs to know that this is going to be a public folder somewhere where the user's request can directly hit. Go to the public folder, we're going to create another folder, we're going to call it models. Well, we're just going to use one model, but still. And then we're going to create another folder, and we're going to name it car, you can name it whatever you like, and inside that we're going to extract all 4 of these. Now, we have the binary file, we have the GLTF file. The GLTF file is actually a text file, which, well, it contains information about how this scene is supposed to be set up. That includes setting the textures. If you don't know what textures are just, images of the surface. And I think in regards to this, I think I should discuss a bit about what these are. I mean, well, what are these strange images? These images look nothing like the surface of the car, this beautiful car we see here. So what's happening? I mean, it's a beautiful looking car, but none of what you see here looks to be anything you see on the side. So what's happening here? Well, let's talk about, let me just go back to GIMP. I think it's time I talk to you about textures before even going to the file. Now, what textures are, if when you're creating a material, like we talked about meshes needing both a material and a geometry. So when you create a material, you can either create the material yourself, which we did with the sphere. We chose a kind of material, we chose its metalness, its roughness, we gave it some colors, whatever. But what you can also do is use images as the surface for any object. And this is what these guys have done here. The one who made this car chose this kind of a surface for the car, this kind of a material, somewhat metallic, somewhat rough towards the, I mean, you can see that, right? So this guy, they did that. I mean, they did that. And like look at the wheels, look at the lights, look at everything. Everything has a texture of its own. And these textures are in the form of images. And these images, well, you have multiple kinds of uh, what are called maps. Maps is a more correct term to use, and you have different maps and they're used for different purposes. Let me give you a quick run over the different kinds of maps. You don't need this for this tutorial, but it's important to know because someday you might be needing your own maps, or if you might want to explore maps later. So let's look at an image of a football. What a random thing to say, but I'm going to need this example. I'm just going to type in football and I'm going to go to images and I'm going to go to this. Now, if you look at this right here, this image on the right hand side, you're going to see that it's a sphere geometry. So it's the same as this, not as metallic, but yeah, it's the same shape. But how can you create this black colored patches and these lines? How you can do that with this if I asked you? Well, there is a native way of doing that with Three.js. You have to work really hard with Three.js if you want to simulate this. An easier way of doing it is just using an image that fits into the sphere. And that's what we call maps. And there are different kinds of maps, like I said. Now, some maps give the surface the color that we want to give it. These maps are called the color maps. So if this football, but let me take you another side. You might be needing this for textures someday. So I'm just leaving you in a position that you can explore Three.js on your own. This site is called 3dtextures.me. That's a beautiful site as well. Let's look at this. And these are collections of 3D surfaces that you can directly use for any mesh. Now there are clouds, there are stones. We're going to be looking for, say, let's look at this. Let's look at rock number 44. You see this, if you look at this, it's not flat, right? It's not flat. It has this rocky texture. So it's rough, plus it's raised at some point and lowered at some point. What I mean is that you have dents in these rocks, right? Some portions are elevated, some are depressed, and you see this, right? Now, there are maps. So these are the kind of maps that you will get if you download this rock 44 texture. And let me just quickly go over what these maps are. Roughness maps dictates, well, which portions of the surface are rough and which are, well, not so rough. And displacement maps are, images that represent how much to really move the nodes. I think I'm not doing a good job explaining. So let's think about this. This is a surface, right? It's a straight surface. The image which you download, let me just quickly download and show it to you guys. I'm talking about it won't help. Talking won't help. It's in Google Drive. Fantastic. Okay. A displacement map. Do you have a displacement map? Okay. I think displacement maps are also called. I think this is the bump and the displacement. I don't see the displacement. I think there's another name for displacement. I think the height map is what displacement is. Let me just do a quick Google search. Height map and displacement map. Yeah, I think is height map the same? Are usually used regardless of the code. They're both fundamentally the same thing. Okay, so yes, like I thought, height maps are displacement maps. If you look at this picture, your eyes will immediately identify that some portions are raised, some are not so raised. The black are depressed, the white are, what a racist thing to say. When I mean black, just don't cut this text out of context, okay? Now, this darker color here, well, represents depressions. The whiter color here, this lighter color here represents elevations. So, when you take this image out and put it on a surface like the sphere here, what you can do is you can actually simulate dents and elevations on the surface. You don't have to manually code that. So say if this was a sphere and you have a width segment, that this is I'm showing you the surface from the from the side. So if these were the segments, what a displacement map does is that it either raises or lowers these nodes. So what is a straight line would become, after processing, it would become something like this, which is exactly the kind of texture that we want. I mean, which is the kind of texture that you get out of this rock 44 texture here. This is what you want, right? You want your rock to be rocky. It's not a solid. So you have displacement maps. Similarly, you have what's called a color map. These guys have named it the base color, but it's called a color map. This map, although it looks 3D, is just for color. This map will only give your object some color. That's it. You will just get color, and that's it. No elevation, no shadows, anything, just color. Then you have something called the roughness map. Well, roughness is, well, we explored what roughness was in the previous tutorial. What this will do is just simply say which portions of the surface are rough and which are less rough. Normal map, well, people used to use what's called a bump map before. People now use what's called this a normal map, and what normal map does is that if you come back to the diagram here, now the way light interacts with real life objects also depend upon the shape of the surface, right? I mean, imagine this. It's a sphere, right? And let's take another object. Let's take a box. Let's assume that both the sphere and the box are made of metal. If light was coming here in this way on the box, it wouldn't reflect back along the same way. It wouldn't. What it will do is maybe reflect around this, right? Because it's a sphere, it would reflect like this because the surface is curved. On the other hand, for maybe a plane surface, the nature of reflection would be, well, I think it would be the same, because, well, for a sphere, the reflection happens tangentially. So this reflection and this reflection will be the same. But what if we take more than one ray? Let's have more. Let's say we chose spotlight, right? What spotlight is you have one single point and the light comes in a frustum like this. Remember? Let me choose a different color, and I'm gonna okay. You have a light like this. You have a ray like this. This ray might be reflected to here. This ray might be reflected to here. So you're gonna see a completely different way of reflection. It's different than what you received, right? If a spotlight was here, on the other hand, on a plane surface, you will see the reflection to be a bit different, right? So let's say if the surface was jagged like this, well, if a spotlight shone on this, you'll have different erratic reflections. I mean, so you get the point, right? The shape of the surface dictates the reflection of the light for real surfaces, for real life surfaces. When you do the same with Three.js, where displacing the surface nodes is not enough, because Three.js won't know that even if these surfaces are raised, Three.js will still treat the surface to be a straight line. So if light was supposed to fall like this here, and maybe like say this here, in the real world, this light would reflect here, this light would reflect here. But if you do the same in Three.js, without applying a normal map, this light would still pass here and this light would also pass here, because Three.js doesn't know the new normal. What I mean by normal is, a normal is simply a line that is at 90 degrees with the surface. So if a surface is this, the normal to this line right here would be this, which makes a 90 degrees. Ignore the bad drawing, but this is what normal is. Light reflects along the normal of surfaces, right? I mean, along that line. You're gonna have to tell Three.js that the normal, when this is raised, is no longer this, but rather this, for this small segment here. For this small segment, the normal is this. For this small segment, the normal is this. And you see that the normals also need to change when the elevation of the surface changes. And that's exactly what a normal map does. It changes the normals of the surfaces to give it an illusion that the surface is really raised when you shine a light on it. So you have displacement map, also called height map, you have base map, you have normal map. This is just a representation of the model. This is not an actual texture file. Don't use it. Ambient occlusion, I think gamers would know this term, and it's for shadows, if I'm not mistaken. Because when you have a surface like this, well, besides light casting its shadow, in the real life, you will also see that certain surfaces have what's called contact shadows. And what contact shadows are is if you place two different objects very close to one another, you're going to see the shadow of two of them on each other. You're going to see a little bit of dark zone. I mean, it's really difficult to, simulate that with light. What you do that is you use a technique called ambient occlusion. And what it does is that whenever you have surfaces like this, it places small shadows in those cracks and crevices when two surfaces meet together. And you have this ambient occlusion map that makes this. You see that these elevations have these small black colored, very gray colored small regions, and these are where shadows would be simulated. They won't be real shadows, they are simulated shadows that give an illusion that you are really seeing this. If you zoom into the picture, you're gonna see some portions of this are dark. You see this? This is dark. It's ambient occlusion. Gamers would know this term pretty well. And I think, did I explain all the maps? Yeah, I did. So now you know what maps are. I won't be using it for this tutorial, but someday you might be wanting to use those. And the way you set the maps is, well, place the maps, the images, in your public directory, import them as images, and step number 3 is you would come to, say, you want your maps, say, with a mesh standard material. You have different map properties that you can use. Type in map and your autocorrect should show it. You have map that symbolizes a color map. You have environment map. I'm not sure what the environment map is. I think it's an image that reflects on the we talked about environments the last day, right? With the new update of React-Three-Drei, you can, well, declaratively create your environment like we created here. So you might not be needing an environment map. Prior to doing this with environment, with this environment component here, we used to use environment map. Now maybe you won't need it, maybe. But maybe you might. Say you have a metallic ball flying and you want to show the reflection of everything around it. Maybe you want that. In that case, you would use an environment map. You have the bump map, which is the normal map. Don't use a bump map. Use a normal map. Yeah. You have the light map. Not sure what that is. You have the normal map. You have the emissive map. If you don't know what emissive map is that, when you want an object to radiate light of its own, you can use what's called an emissive property. So you can use the emissive map. Go and explore these topics. Even I don't know everything of Three.js. It's like I know just maybe 5% of what Three.js is actually capable of doing. It's a huge field of its own, and it's awesome. You have roughness map, you have metalness map, displacement map, and so on. So what you do is that you choose this map properties, and as the prop, all you do is pass in the you need to pass in texture file. And the way you do that with React-Three-Drei is, once you have the file paths from here, from the import, what you do is that you use something called a use texture hook. So for example, say we had a texture called the color map texture. Say we have had this. You would use a use texture hook from React-Three-Drei, like here. And all you would do is, look at this snippet here. It says that all you need to do is pass in a single input string or an array of string. And you need a single string when you are loading one texture. If you're loading multiple images at the same time, you can just pass in an array of textures, array of texture image path locations, and what you would get back is also an array of textures that you can then use. And these are promises, I think, right? No, straightforward gives you the texture. It resolves the promise internally. So just use that. Say for example, we had an array of different paths. Let's assume it's a path, and let's assume this is a path, and what you would get back would also be, say, color map texture. Maybe you were loading, say for example, the displacement map texture. Once you have these files, you're going to see that they are of the type Three.texture. These files you can then copy the reference of and then pass it as the map. If you place your mouse on the map, you will see that it needs a Three.texture, and this is exactly what we passed it. So this is how you can pass your own textures. For this tutorial, we obviously won't need, but I thought this is a good time to show you what textures really mean. All right, now let's come back to where, go back to where we diverted from, that is showing our car. I'm talking way too much in this video, but that's what it is. We can have to discuss this. I have a call right now. I'm going to pause the video and come back. I'm back again. It was a phone call from... okay, leave it, whatever. Okay, so we have the car right here. I placed it inside here. So we have textures, and you now know what the textures are. You don't have to load them individually. When you are using a GLTF file like this, this in turn will reference all the other textures. So you don't have to do that on your own. All you have to do is use this GLTF file. But we will be using an extension called GLB, that is a binary version that will combine all of these into one file that the user can fetch at one go, which will be a bit more compressed than all these three taken together. We're going to use that. But like I said, there's a VS Code extension I was talking about, right? So if I open VS Code, wait a minute, I do have VS Code already open, yeah. So if I go to that directory, it is in it's in yeah, this is the GLTF file. If I open the file here, then press Ctrl Shift P and go to GLTF preview 3D model. Okay, if I go to preview 3D model here, you're gonna see this beautiful model open up of the car that you can actually move and interact with in real time. And it's Babylon.js. We're gonna shift to Three.js. And okay, right now it's, yeah, and this looks awesome. And this model is really big. Like I can even see that you know, I'm getting frame drops on the rendering here. It's not as smooth as you would expect it, because there are way too many vertices on this. But yeah, you can use this extension to see GLTF extensions. If you don't know how it looks and you want to see GLTF files, you can do this from inside VS Code. Now let's convert these GLTF and every other file to a GLB file. So open with your terminal. I'm going to open another tab and navigate to this directory where we have this. So public models car. Let's list out the files, and we have this. Now when you use React-Three Fiber, we need to represent this file in components, right? And the way we do that is, first, we need to convert this to GLB. So that's step one. And step two is turning that GLB into its component form. So let's go to step one first. You're going to need to use something called the GLTF pipeline. If you don't have this already, I think if you haven't worked with GLTF, you wouldn't have it in the first place. So use your favorite package manager, Yarn, NPM, whatever. You use Yarn. If you use Vite, you would have used Yarn. Use that and maybe install this globally, GLTF pipeline. Just install that globally. Or what this allows you to do is it takes GLTF and it makes a binary GLB format. If you just type in help, we're going to need the help, because then I'm going to say GLTF pipeline. One of its parameters is the I, which you use to pass in the input file. And you need to pass the GLTF file, so scene.gltf as the input. The output would be, say, car.glb, and or maybe model.glb. And we can add some compression here. So we'll say the compression level right here would be the highest that it can offer, which is 10. You can't have a compression level higher than 10 here, and maybe, and yeah, we're gonna do that. And we need another parameter called the B. The B, I think it's B. Yeah, the B states that the conversion would be binary, so it would be from GLTF to GLB. By default, it's false, so it's something to note that you have to pass B. Do that. It's gonna take some time, and then you have this. this GLB file here of 61.9 MB, and let's look at the combined file sizes of these three. Go to properties, and the total of 74.2 was the total size. We compressed that to a single file of 61 MB. So that's a saving of around 12 to 13 megabytes, which is a lot. If you're saving 12 MB, that's a lot. So we're going to be using that. We don't need a license for this, and we can do away with the scene.bin, the scene GLTF, because this singular file represents all of that. And then what you're going to do is step one's done. Step two is we need a component form of this file, right? We need to use tell our React-Three to take out stuff from here and turn them into components. And for this, you're going to have to install another global package. It's called GLTF JSX. Go ahead and install that with npm globally, or your whatever package manager you use, and then you type in GLTF JSX and point it to the file that you want to convert to a JavaScript component. We'll do that model.glb, press enter. It's going to take some time, and then we have this this model.js file that is actually a component. So if you cat out that model.glb file, or model.js, I'm so sorry, you'll see, I mean, don't delete this GLB file. This file is not a replacement for this. What this file will do is give you the component or the component that you need to render out in order to show this GLB file. So you need both of these. So right now it's a gigantic file. It's a I mean, I've never used a model this big in my life. I'm only using this for this tutorial. In a real life, a model this big wouldn't be practical for web unless you're creating a video game, like I said. So now we have three here, and inside component we have three. We have index, but we're going to create another one since this component is way too big to be in the same file. So we're going to create a car.jsx. Inside here we'll be pasting everything that we got out of that file. So it was in model.js. We could have simply cut this file, pasted here, and deleted this, rename this to car.jsx, remember? But yeah, I think JS and JSX really doesn't matter, but it's for your own sanity. So car.jsx. Now let's look at car.jsx to have a brief overview of what it really uses. Now, well, React, use ref, you know what those are. Use GLTF is another hook, just like use texture hook that we just explored a few minutes ago. And what use GLTF does is that it loads GLTF or GLB files, just like use texture loaded image files. So you have use GLTF, it gives you nodes and materials, a huge collection of nodes and materials, and then you have all of these components internally rendered that take out stuff from the GLB file and render them accordingly. You don't have to mess with any one of these. Remember not to mess with this. You're going to mess things up, so don't do that. What you can do is, well, you can pass props to this model. We're going to name this as a car. And yeah, you can pass props here, and we're going to see why props are useful in just a second. But you can pass props here, and then you can modify the car. But don't mess any one of these properties, okay? I'm going to press save, and we have the car.jsx ready. Now all we have to do is render them here. So we'll say import car from car. We have the car component here, and I'm gonna somerset my door. I'm coming in just a bit. Back again. All right, so we're gonna render out the car. We have the ball here. Makes sense to have the car here. But feel free to just change the order of the rendering. It really doesn't matter. So we're going to comment this car. We have car. Now, one thing is that when you load models, you're not going to have control over the dimensions of the model right away. I mean, look at the sphere. We knew that the radius of the sphere, I think it's 1, right? If you look at the ball, no, the radius is 0.5. So you had control over the size of this. But since you didn't create the model, you wouldn't have control over the size of the model initially. So when you place a model like this straightforward, you might find that the size of the model that gets rendered might be way too small, or way too big, and it might not even render, might be because its size is way too small, or if it's too big, you're not going to see anything on screen. I mean, if it does happen, remember that your model by default, like any other thing, is going to be placed by default at a location 0, 0, 0. So if you can't see the object, play around with the scale. Sometimes you need the correct scale. The default scale is 1, but we'll see how useful that is. If we save it, our car should have been loaded. Horrible, is it? And we do have an error. And it says model.glb not found, and I did a terrible mistake here. If you open the car.js, one thing you have to remember is that you have to point this to the correct file. We don't have anything on model.glb. We don't have that. We have that in our models, car, and then model.glb. That's the path we had. So models, car, glb. Yeah, that's correct. Save and refresh. It's still not found. That's weird. What's happening? Let's do a fresh refresh. And it says, well, model.glb not found, but I'm not finding it from. There's another path here. Copy the same, paste it here. You need to take care of the file path. Almost forgot. Refresh. Please don't error out. Cannot read properties of undefined reading elements. Is the file way too big for Three.js? I mean, at matrix3.copy cannot read properties of undefined. This is a new error I'm seeing. Let's quickly reading elements. Where do we have elements? We don't. It's something used internally. And we do have the correct stuff, so maybe the model we were using isn't correct. Maybe, because this should have worked. Let's quickly go over and download another model. I mean, let's not waste time. So now you know what to do, right? You know what to do. We're going to do this very fast this time. I'm not going to waste too much time. So I'll just pause the video here, go ahead and download a model and then come back.
One eternity later.
I just wasted maybe around 45 minutes trying to figure out what was wrong. I thought the model was maybe corrupted something. And I tried maybe 6 to 7 different models, but none worked at all. Then I deleted the model, but it still didn't load. And I wasted so much time, and then I finally found the error. And I am angry at myself for what I did. Remember when I explained to you different kinds of textures that you had? I explained with this map prop, but I never took it off. So when you pass a prop like this, you are passing true. That's how React works. If you pass a prop with just its name but no value, it assumes that the value you are passing to map is true. But map cannot be true, it's a texture. So there is nothing to load from that texture. You delete it, and then it works. I am stupid. It will work now. Just wasted my time. But before I took you to the car, I mean, you remember what I was talking about, right? You use GLTF JSX, but I just learned of another parameter. With GLTF JSX, instead of just passing your GLB or your GLTF file, what you can also do is pass in this -t parameter, which as it says, will transform the asset from the web. So it has its own presets that does stuff. Maybe, I don't know, some magic happens internally. And let's also pass in this. Let meshes cast and receive shadows. Yes, we will be needing shadows as well. So we have, it says the use npx gltf jsx and then the options. Okay, so the options will come later. It needs the name of the file, so we'll be doing that. So model.glb with attack t and attack, what was it? And the shadows, so we'll be doing that. Hopefully this works. Everything correct? Okay, lots of transformation going on, I see. Not straightforward. There is a model transform.glb. Is it creating a new glb file of its own? That's awesome. So it has its own glb file. That is an even compressed version. Wow. Okay, looks like we didn't need GLTF pipeline at all. I just learned this. You don't need GLTF pipeline. You can use GLTF JSX to create your own compressed GLB files. Whoa. And that's 17 MB versus what we had the GLB of 61 MB. That's a massive compression. Wow. This changes everything. Let's try it out. Let's try it out. I am excited. Okay, so we have the model.js, which we need to cut out from here. We paste it here. We'll rename this to, it's a car. We'll call it car.jsx maybe. We need to make sure that the path names are correct. So, holy shit, that's a huge file. Okay, the path name has to be correct. So it's models. You see on the left hand side the file explorer. It's models car, then model gl transform.glb. Okay, looks like to be correct. We'll save this. And props, we don't need props because everything that we use will be modifying in this component itself. We'll name this car. We don't need the props. And our car component is ready. We'll be rendering the car here. CAR. Yep, we do. Save. Anything unused? Nope. Everything okay here? Yeah, looks like it. And yeah, let's test it out. I am tired at this point, you know. It's been a whole big day. Alright, let's see. We removed that map prop from there. That was the mistake. And this should load now. We didn't start the dev server. Also, one more thing I did. I'll just talk to you about it later. Okay, let's start with the yarn dev. It is running. Refresh. Please load and don't edit out. Okay. Okay, that's definitely something. The car is way too big. Like I said, some models would have an erratic size. You have to control that. The way you can do that is use this group here. Well, you can use the group element to group together different meshes inside one component if you want. It's just like how you would use fragments or maybe div elements in the DOM to group together stuff. You can use a group here to group together meshes. And you'll be using, and whatever parameter that you need to pass to your car would be passed to the group. Remember that. So we'll be decreasing the scale, right? Whatever parameters you can pass to the mesh, you can also pass to group. So scale, and let's decrease the scale to maybe 0.5 half the scale of what it is currently. Okay. Okay. The shadow doesn't look at all realistic. You see that? You see that rectangular light over there? But I think the model is rectangular. What I mean is that maybe, and look at the shadows. It's not supposed to have shadows, but it is rendering its own shadows. That's why the car looks this weird. And maybe if I disable shadows, will it not work? Cast shadow. If we pass that to be false, we don't need shadow. But nah, it's not dynamic shadow. It's shadow of its own, and that's why it looks a little bit ugly. I mean, it's ugly to me in the sense that it shouldn't have its own shadow, right? I mean, what's the point? What's the point? I'll be animating on my own, so what's the point of this? Wait, just wait a minute. Alright, I'm back again. I chose this weird looking car. It looked futuristic enough, and I thought maybe this is a good one. So we'll be using this one going ahead. We don't need props here. We don't need props here. And then we'll pass our own props like we discussed. We use a scale of maybe 0.6 maybe. And okay, the shadows are a bit more realistic than the last one, obviously. Wait a minute. We need to set a lot of parameters. So let's set the scale to be 1, but let's also set the position to be a little bit away from the screen because we have the ball right here. So we'll quickly do things now. This video is going over way too long, and so we have 0, 0, and maybe a -2 on the negative z-axis, so it goes away from the screen. We have the scale to be 1, and finally we need some rotation because currently, if you see, the car is facing forwards. I mean, that is the normal of the car. Now, if you want to rotate it and make sure that the car is pointing towards the left-hand side, we would need a rotation around the z-axis. If you remember my video about the rotation, what you need to do is rotate it along the y-axis. I'm mistaken, not the z-axis, the y-axis. The y is the perpendicular, right? So when we're rotating along the y, so we have 0 on the x, we have something on the y, and we have 0 on the z, and this something is again angle to radians, that function, if you remember, and we're going to be rotating in 90 degrees. So here's 90, and save. And the rotation is correct. We just need to drag it a bit x, y, z. So we're gonna have to drag it to the right hand side to make sure that the car comes in the center, because right now it's towards the left, right? So we'll be dragging it towards the right, so we need a positive x. So let's try with the positive 4. Save. Way too much. Positive 2. Almost. Well, I think it does the job. Maybe I'll decrease the size of the car a bit. Maybe a 0.85. Maybe. Let's see. Maybe. What I can do is maybe rotate a bit by. Maybe I can keep this 120. Or maybe 140. I'm just playing around with the values at this point. Yeah, maybe 130 degrees with a negative distance of a bit more so that it goes further away from the screen. And I just want to show the front of the car. And maybe 140, but this time towards 0. Let's see. I think it does a good, decent job. Maybe a few more lights would help, but you get the point, right? I'm not trying to extend the tutorial. You get the point. You have its shadows, like you see on screen. It has its own shadows on the object. But whatever light you use, you see that the original color of the car was kind of blackish. But since we have a blue colored environment, you have this blue colored glow on the surface of the car. So I think we can conclude the tutorial here. Is there anything left I'm missing out? Well, you can customize your things further from here. You can add animations. Maybe you can take this as a task. Maybe you try experimenting with GSAP, how you can drive the car. I mean, obviously you can't rotate the wheels. Maybe you can find the mesh among all of this. Which one is the mesh for the wheel? Maybe you can animate the wheel, then maybe you can animate the car going forward with GSAP. I mean, now you know what to do. To animate the wheel, you need a circular motion, and to animate the car, you would need a linear motion. You know how to do that with GSAP, right? You saw the position, the rotation props being animated. You saw that. You can do the same with the car. Maybe try doing that. So that's it for the tutorial. It's been way too long for me and because of that texture prop, but whatever. We learned a lot in this series. We learned how to make our own scenes with Three.js, and we learned using React for that, and we learned a couple of helpers. Now I started. I used to think that GLTF pipeline was a good way of transforming GLTF to GLB, but now I see that GLTF JSX itself has the ability to convert GLTF to GLB files while keeping it compressed by a lot. So don't use GLTF pipeline, use GLTF JSX. I never read the help file, so I guess I learned a lot today. So thanks for watching this entire tutorial. If you have any questions, anything to say, any criticism or anything that I could have done better or any suggestions, or maybe if this video helped you, whatever, just comment it out or reach out to me on Twitter, send me a DM or tweet about it, whatever. Just do it. And thanks. I'll maybe see you in some other tutorial someday. Bye.